In this video, we're going to talk about congruent triangles. Two triangles are congruent if one coincides with another triangle. That means that it fits perfectly over the other. Let's try to look at this a little bit visually. So let's suppose that we have this triangle. Okay, so I'm drawing a triangle like that, and we have another triangle. So we have another triangle that is basically if you notice, they're pretty similar, right? So congruent triangles, like I said, means that they fit perfectly over. So it means that if I have an angle here on this corner, on the right corner, let's mark it with that. It needs to fit to this angle right here, okay? If I mark this angle on the left side and I mark this on the right side, they need to fit perfectly one another. If I take this whole triangle and I put it on top, I flip it and I put it on top, then this angle would match with this one. The same goes with this angle on top. Mark it with 3 lines. It's going to fit with this. Okay. So if I put names to this, let's call this A, B, and C. And let's call this one D, E, F. Okay. Then I should say that angle A corresponds with angle D. Okay. That angle B corresponds with angle E. And then angle C corresponds with angle F. Okay. Also, since it needs to fit perfectly, not just the angles, also the sides, right? So this side should fit with this side. Okay. This side should fit with this side, and this side should fit with this side right here. Okay, if this happens, then we said that the triangles are congruent. We use this notation to say that. So triangle, let's suppose triangle ABC is going to be congruent, and the order matters. If A corresponds with D, then I need to start with D. So with triangle D, B correspond with E, so DE. C correspond with F, so DEF. Okay, so I cannot write it like, okay, this is congruent with triangle DFE. Why not? Because B and F are not corresponding. Okay, so order matters. DEF. Okay, so this is how we write, or the notation that we use to say that the two triangles are congruent. Remember, each side must fit perfectly with another side on the other triangle, and the same goes with the angles. Okay. For this, we are going to talk about a couple of postulates. So the first postulate says that if 3 sides of one triangle are congruent to the 3 sides of a second triangle, then the triangles are congruent. So it's enough if we know that the 3 sides are congruent with 3 other sides, okay? And this is called the SSS criteria. That means side, side, side. So if we have just this, we have that triangle, okay? And we have another triangle like that. And we know that the sides are congruent. So these 2 sides are congruent, right? And these are congruent. Then the 2 triangles are congruent. That is enough. That is enough to say that those 2 triangles are congruent. Okay, this is the side, side, side criteria. The next postulate says, if 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the triangles are congruent. Okay, so what it's saying is 2 sides and included angle. An included angle, if I have 2 sides like this, an included angle is this. Okay, so that is an included angle. So I have 2 sides and one included angle is going to be congruent with, let me try to draw it here as similar as possible to this one. So this side is congruent with this side. Okay, 2 sides and included angle. So the 2 sides are congruent. Okay, so this side with this side. And the angle is congruent with the included angle is congruent with the included angle. So if this happens, okay, then the two triangles are congruent. This is enough to guarantee that the two triangles are congruent. Okay, so this is, if this is triangle ABC and this is triangle DEF, then it's enough to say that if we have these two sides and included angle, we say that triangle ABC, it's congruent with triangle DEF. Okay, so remember, this is called the side angle side criteria. So if we have side angle side, then the triangles are congruent. Okay, next one. It says if two angles and the included sides of one triangle are congruent to two angles and the included sides of a second triangle, then the triangles are congruent. In this case, this is what we have. We have a side, okay? We have a side and we have the angles, because it said we have two angles and the included side, the one in the middle. Okay, and now we have another one pretty similar, okay? And with the same condition, the two angles and a side. If we know that this angle is congruent with this one, this angle is congruent with this one, and the included side is congruent, I mean, these two are congruent, then they are congruent. Okay, the two triangles are congruent, and this is called the angle side angle criteria for congruence. So again, so if this is A, B, and C, and this is D, E, and F, then we said that triangle ABC, it's congruent with triangle D, E, F. Okay. How do we call this criteria? The ASA criteria, angle, side, angle. Okay, so let's review real quick. We have three, for now, we have three postulates that help us determine if two triangles are congruent with some conditions. So if we have side, 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 then the triangles are congruent. If we have side, angle, side, that means a side, an angle in the middle, included angle, and another side, then with another triangle, then they are congruent. So side, angle, side. And if we have angle, side, angle, angle, side, angle with another triangle, angle, side, angle, then they are congruent. Okay, these three postulates lead us to come up with a theorem. Okay, that theorem states that if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of a second triangle, then the triangles are congruent. So what it's saying is this. Let's suppose that we have a triangle. Let's suppose that we have a triangle like this, right? And we have another triangle. Okay, so we have another triangle. Let me try to draw it properly. We have another triangle like that. Okay. And this happens. Maybe this happens. If two angles, so two angles, this is maybe congruent with this, and this is maybe congruent with this, okay? And so if two angles and a not included side, so not included side, this side is not included in between these two, and this side is not included on this two, then the two triangles are congruent, okay? The two triangles are congruent. This is pretty evident since we already know a theorem that states that the sum of the interior angles of a triangle, it's 180 degrees, right? And if we already know the measure of these two pairs of angles and we know that they are congruent, then the only possibility is that this is also congruent with this one. Okay, there's no other option. If this is, I don't know, this is 40 degrees, and this is 120, and we know that it's congruent with this ones, so this is 120 and this is 40. There's no other option. There's no other option that this angle must be 20 and this angle must be 20. Okay, so the triangle must be congruent since the angle now, this one that is right here, the not included one, it's congruent. So we can guarantee just because of this piece of information that the triangle is congruent. Okay, notice that this must be followed because there's no criteria but for angle, angle, angle. If you have the same angles, the angles are congruent, they're corresponding. And in between two triangles, the triangles can have different measures for the sides. So there's no congruency when this happens, and you need to be really careful with that. Okay, so for this, and let's put names to this. So this is M, this is N, this is P, let's call this K, Q, and I don't know, W, then the triangle BNM must be congruent with the triangle QKW. Remember that the order matters, okay? So in the next video, we're going to solve a couple problems and proofs related to this theorem and the other three postulates that we just discussed.